This is Algebra 2, Lesson 10.5, Correlation. So correlation is a measure of how related two variables are. So we can talk about, in children, height and weight. Usually there is a relationship between your height and weight. Usually the taller you are, the heavier you are. Now that's not always the case because there are shorter people that are heavier and there are taller people that are more slender. But I said in children because if you have a 1-year-old, they're pretty short, they weigh less. If you have a 12-year-old, they're definitely a lot taller and they probably weigh a lot more. So there is a correlation here, but there is not a causation. It doesn't mean being taller will cause you to be heavier, because we do have slender people and heavier people. And being heavier or skinnier does not cause you to be shorter or taller. Correlation coefficient is the value that we're going to assign to these relationships. So we use the letter R, lowercase letter r, to represent correlation. If R is 1, that means you have a perfect correlation. So every time one of your variables increase, the other variable will increase the exact same amount, or relatively proportionally the exact same amount. If your correlation is between 0.7 and 0.9, that's a very strong correlation. If your correlation is between 0.4 and 0.6, that is a moderate or medium correlation. Between 0.1 and 0.3, kind of weak. And if your correlation is 0, that means there is no discernible relationship pattern between your two variables. We can also look at data. We can determine its correlation. We can calculate it, but we can also estimate it with a picture, and we can talk about things like positive, negative, strong, weak, depending on how close the data fits to a line. So I would say, looking at these first two graphs here, those are very strong correlations. But if you notice, one is pointing upward and one is pointing downward. This is a positive correlation, meaning as one variable increases, the other also increases. So think of it like height and weight. The taller you are, the heavier you are. This is a negative correlation, and that would be as one increases, the other decreases. Easy one is usually your golf score. The more you practice, the lower your score is, because a low golf score is a good golf score. So the more of something, the less of something, that's a negative correlation. And this one would be pretty neutral or negative, or sorry, neutral or none, because there really isn't a discernible positive or negative pattern there. We can also talk about them in terms of strong, medium, and weak. So if I look at this first one here, that is a little stronger than the first, or than the next. This is a little more medium. And this is a little more weak. So without numbers, we don't have numbers along these axes, it's not possible to calculate our correlations. It is possible to calculate, but if you guys remember the standard deviation formulas from a couple sections ago, those were crazy complicated, and the correlation calculation is even more complicated. So rather than having us calculate them, I'm going to just have us do some estimating. So I said this is pretty strong, let's go with 0.9. I said this is pretty medium, let's go with 0.6. And this is kind of weak, let's go with 0.3. Now you could have two very strong graphs and say one's stronger than the other, so say one's a 0.9 and one's a 0.8. Or even a 0.85, or even a 0.936. It doesn't have to stop there. It just has to be between those values. So our final one, we're going to estimate the correlation coefficient for each graph. Oh, not the final one. We got two more. So this is a perfect correlation. Each of these dots fall perfectly on a line. This is R equals 1. I'm going to eyeball a line in here. Most of those data are very close to the line. Let's give it a 0.8. This one, they're a lot farther away. Let's give that a 0.4. And here we got even more, but I do know that this is a vertical or a positive correlation because I see voids here and here. There's definitely an upward trend to the data. If I had a few more dots, maybe I had some more up here and some more down here, now there really isn't a discernible pattern, but without those dots, this one definitely has a weak positive correlation, so I'd give that a 0.1 or 0.2, somewhere in there. So like I said, I'm not looking for a specific value. If we determine this as weak, you can say 0.1, 0.2, 0.3. We'll give you credit for all of those. And our last one here shows the correlation between ice cream sales and visits to the nurse to treat sunburn at a certain summer camp is R equals 0.0866. Does that mean that ice cream sales cause sunburn? Can you identify a lurking variable? So we talked already that there is no causation with correlation. This is definitely a very strong positive correlation. More ice cream, more sunburn. But ice cream doesn't cause sunburn. There's a lurking variable, which is like an outside factor that's causing both of those things to happen. And my guess would be that is sunshine. More sunshine leads to more ice cream consumption. More sunshine leads to more sunburn. That's not the only possibility. It could just be summertime. It could be the temperature. There's lots of possibilities. So the objective is just to name any possible lurking variable that would be causing each of these things to happen independently, but not causing sunburn from eating ice cream. Okay, that's it for the notes. Good luck on the exercises, and please let me know if you have any questions.